Let's discuss some problems regarding fractions. What is the distance around a triangular lot with the following measurements? 3 and 1/4 meters, 7 meters, and 5 and 1/8 meters. So basically, this is a problem that involves finding for the perimeter of a triangle. And the basic knowledge that we need to have is the addition of fractions. So before we go to this problem, let's go first to the different details on how we could possibly add fractions. So let's have case number 1. We have adding similar fractions. So by definition, we know that we say that fractions are similar when they have the same denominators. So for example, when you have 5/8, and this is added to 1/8, we can say that these two fractions are similar, which means that these are actually divided in equal parts. So 5/8, while the other one is 1/8. So in this case, we simply have to copy the common denominator. So 8 is the common denominator. We just have to copy that, and adding 5 and 1, that is equivalent now to 6. So therefore, the answer for this is 6/8. Or we could just simplify 6/8 by dividing this by the GCF. So the GCF of 6 and 8 is actually 2. So when you say GCF, this is the common number, or the greatest common number that can divide both the numerator and the denominator. That this does not affect the value of the fraction, because as we notice, when you have 2/2, this is basically actually equivalent to 1. So we are just dividing the same number, or 6/8, by 1, but in terms of a fraction, which is 2/2. Now, when you have 6/2, that the answer is equivalent to 3, and 8 divided by 2, the answer is 4. So the answer that we are getting is 3/4. That's the sum for 5/8 plus 1/8. Now, suppose we have similar fractions, but with a combination of a whole number, which means a mixed number. Let's say, for instance, 5 and 1/7 plus, let's say this one is 2 and 6/7. So what do we need to do? So we have to combine the whole numbers. So 5 and 2 will be added, because these are actually the whole numbers. So we just have 5 plus 2, and that will sum up to 7. And adding the numerators, you have 1 and 6. That is also equal to 7. And then 7, you just have to copy, because that's the common denominator. Now, this has to be changed, because as you notice, your 7/7 here already will make a 1. Okay, 7/7 is 1. So added to the existing whole number, which is 7, the final answer will be equivalent to 8. So that is how we add fractions with the same denominators, or similar fractions. The question is, what if we are dealing with fractions with the similar denominators, or we call them the similar fractions? So that will be our case number 2. So if, for example, you are given 3/7, and we are adding this to 5/14. So as you notice, the denominator in the first fraction is 7, which means that the whole thing was divided into 7 parts. Okay, and the other one is 5/14. It was divided into 14 parts. So in this case, there is a need for us to figure out the number which actually divides both the numerator and the denominator, and the LCD comes in. So LCD actually refers to the least common denominator or multiple of the denominator. Again, LCD, least common multiple of the denominator. So we can make use of our decomposition method, though for some you can actually look for a certain multiple of 7 and 14, and that is the one which is common to them. So the easiest method is actually the decomposition method or the inverted division method. So just look for a number that can divide both 7 and 14. So obviously you can have 7 here. So you divide 7 divided by 7, it's 1. And then 14 divided by 7, the answer is 2. Now, evaluate now the remaining numbers at the bottom, and if you see that these are already relatively prime, you may stop. And you can figure out the LCD by just multiplying this number. So 7 times 1 times the 2, it's equivalent to 14. Okay, but if you can do that mentally, again, you can use the multiplication sign or the dot symbol, okay, for the multiplication. Now, but if you can do that mentally, there is no problem with it. So we just have to show now the solution for finding for the least common multiple, which is actually necessary. Why? Because there is a need for us to regroup, okay, or rename, I should say. So 3/7 will now be renamed in terms of the denominator 14. So that simply means that we are looking for equivalent fractions. So in this case, 3/7 will be equated to a certain number which has a denominator of 14. Okay, so how do we do it? So it is simple cross multiplication. So we can have 6 times or 3 times 14, which is 42, divided by 7, and the answer that we will be getting there is 6. Or we can do it the other way around. 14 divided by 7, the answer will give us 2, and then you multiply the 2 by this existing numerator, and that is 3. Again, the idea here is we actually are looking for a number that will give us a denominator of 14, because our aim is for them to become similar fractions. So we already have 5 over 14 here. So we don't need to change this anymore because this is already 5 over 14. It's only the 3 over 7. Okay, so this simply means that the 3 over 7 is now changed to 6 over 14, and the 5 over 14 will just be copied. And after that, we can now use the first case a while ago, wherein the rule states that when we are adding similar fractions, all we have to do is to copy the common denominator. So there you have 14, and adding 6 and 5, we will be getting 11. Okay, so in case there are whole numbers, of course, it will just be the same case. Like for example, we have 3. So if there is an existing 3 as a whole number here, and then 7 as another whole number here, that will just be copied. This will be the only one which will be affected. The 6 or the 3 over 7 that is changed now to 6 over 14, but the whole numbers remain. Okay, so we have now 3 and 6 over 14, while the 7 will just be there. Therefore, if you are going to get the sum, we simply have 3 plus 7, that is equivalent to 10. So the answer that we will be getting there is equivalent to 10. 10 and 11 over 14. So actually, those are the only cases which are actually involved when you are adding fractions. Now, in a case wherein you simply have a whole number, let's say for instance, you have 10 plus let's say 3 and 1 over 7. Okay, so in this case, if you have this example, what do we do? Remember, this is a whole number, so again, it should only be added to the existing whole number in the problem. So adding 10 and 3, the answer is 13, so we don't have any problem with that. We just have to copy 13 and then, of course, the fractional part, which is now 1 over 7. Okay, so again, the only thing that you have to remember when you are adding fraction is that they should have the same denominators. So let's have another example. So suppose I have 2 and 1/3, and then I am adding this to 7 and 1/2, and the other one is plus 5, and let's say this one is 3 over 4. Okay, as you notice, there are already 3 denominators which are involved. We have 3, 2, and 4. So don't forget that the first method is finding the least common denominator, and that is involving now the denominators 3. We have the 3 there, and then 2, and then 4. Okay, so evaluate the numbers given, 3, 2, and 4. As you notice, if you are going to look for the greatest common factor of this 3, we only have 1. But if it concerns the LCM, we can actually have 2 and 4. Okay, and we know that these two numbers are divisible by 2. So we can now use 2 as your divisor. Now, if you will have 3 divided by 2, that has a remainder. So in that case, all we have to do is to copy the numbers that we cannot divide. So we will copy the 3 and divide only the ones that can exactly be divided, like in this case. So 2 divided by 2 is 1, so we write 1, and then 4 divided by 2 is equivalent to 2. Okay, so we only have the 3 numbers now, 1, 2, and 3. And again, we call these numbers as relatively prime numbers because their GCF, or the greatest common factor, or the only factor that can divide these 3 numbers, is 1. So we stop. We can now have the or the LCD, or the least common denominator, by simply multiplying all these numbers. Do not forget to include the 2 here. Okay. And if you are going to multiply 2 with 3 is 6 times 1, that's still 6 times 2, it's also equivalent now to 12. So we know now that our least common denominator is equivalent to 12. Next step is to rename. Okay, so we can see that all these 3 do not have 12 as a denominator, which means that all of these numbers will have to be renamed. Okay, so we can now write 2, those whole numbers will have to be retained, and then it's just proper that you will write now 12 as the common denominator, because that is our main aim now. Okay, we want them to be similar fractions. Okay, so 5, and we have a missing numerator there, and then of course we have to copy the denominator that is desired. Okay, again, the step is divide, multiply. Again, divide the denominators, 12 by 3, that is 4, and then we multiply. So 4 times 1 is equal to 4. Okay, which means that 1/3 is equivalent to 4 over 12. Okay, if you are going to get the lowest term of 4 over 12, that results to 1/3. So what we are dealing with now is actually equivalent fractions. Okay, now when you have 12 divided by the 2, that is giving us 6 times 1, it's equivalent to 6. So 6 over 12. Okay, so 6 over 12 when reduced to lowest term gives us 1/2. And then finally, you have 5, and 3/4 will be renamed as 12 divided by 4. That is equivalent to 3 times 3 is 9. So that means that 5 and 3/4 is equal to 5 and 9 over 12. Okay, when we get the lowest term of 9 over 12, of course, we divide both sides by both the numerator and the denominator by 3. That will result to 3/4. Again, we did not change the value of the numbers that we are adding, but we'll look for equivalent fractions because the main thing here is they should be divided in such a way that they are equal. So this one, it's divided into 12, and so with the second and the third. Okay, so again, we have to simply add the whole numbers, 2, 7, and 5. That is now giving us an answer, which is 14. So 14, and the numerators, we have 4 and 6, that is equal to 10. Plus the 9 is equivalent to 19. So 19 over 12. Now, by definition, if you have a mixed number should be a combination of a whole number and a proper fraction. Okay? A proper fraction is always less than 1. And as you notice, 19 over 12 is an example of an improper fraction. Okay, which means that we have to manipulate this 19 over 12, and we need to change that. The 14 will just be retained, but we have to rename the 19 over 12. So try to recall your lesson on changing improper fraction to mixed numbers. So that is simply dividing the numerator by the denominator. So dividing 19 and 12, the answer that we are getting is 1. And then multiplying 1 and 12, of course, you have 12. And you have to subtract. That's the rule for division. So we have now 9 minus 2 is equivalent to 7. 1 minus 1 is 0, so we may not write that. Therefore, the 19 over 12 is actually 1 and 7 over 12. Okay? So, this simply means that we are now adding the existing 14 to the value of 19 over 12, which is actually 1 and 7 over 12. And therefore, the final answer for this is 14 plus 1. That gives us 15. And then, we have to copy 7 over 12. So that is how we could apply addition of fractions. Okay, so let's go back to the problem that we have and apply this rules in addition of fraction. So again, what is the distance around a triangular lot with the following measurements? You have 3 and 1/4 meters, 7 meters, 5 and 1/8 meters. So basically, the lesson that is involved here is actually looking for the perimeter. So if you have a triangle, which is, for example, this, okay, we have now 5 and 1/4, or 3 and 1/4, I should say. So you have 3 and 1/4 meters. That is the shortest side. And then the other one is 7 meters. So let's just have 7 meters, for example, here. And the other one is 5 and 1/8. Now, again, this is perimeter. But when you say perimeter, that is actually adding all the sides. So this is a problem that involves addition of fractions. So what do? We have 3 and 1/4 plus you have 5 and 1/8, and the other one is 7. Okay? So if you are going to check on this, we have a whole number. And you can actually add already the 7, the 3, and the 5. So if you will be getting the sum of 7, 3, and 5, that will already give us 15 meters. Okay? So the sole problem, or the only problem now that we are dealing with, is the sum of 1/4 and 1/8. Okay? So 1/4 plus 1/8. So again, we can now simply just find for the LCD. If you can mentally solve, what's that number that can divide both 4 and 2, or 4 and 8? Then you may do it mentally. So if not, you can do the method, which is the decomposition method. Okay, so here you are expected to get 8. So again, you have to just divide. So 8 divided by 4, that is equal to 2, times 1, it's equal to 2 over 8. So we know now that 1/4 is the same as 2 over 8. And then the 1/8 will just be copied because that has already a denominator of 8. Therefore, the answer that we are getting here is 3 over 8, or 3/8. And we are done. So the answer that we should get is 15 and 3/8. And we don't forget to put the unit of measure, which is in meters.